Oh, you got her! That's in the second class.
I told her to stand next to the screen. She'll be on tape. So she goes, really?
No.
And then she went, oh.
We had a tape last year in Mr. Sun's class.
Yeah. Oh, that's true.
That was
And it was pointed directly at the board.
not Mr. Seth's class.
Yeah, because he was video conferencing with another school.
We had 8th grade.
I may or may not be video conferencing with another school.
You're
Why?
lying.
You just like to
You're
lie.
right. Anyway,
That's the third lie. You could
Yeah,
lie.
I just don't trust you. I'm never going to trust you.
Well, that's fine. You're not getting any presents. That's always equal to something.
I'm going to get coal in my stocking, right?
Yeah.
Ladies and gentlemen, if you need some graph paper, you do need one sheet for some notes and one sheet for homework. So I'm just going to send some around. Take one if you need it. Like I said, you'll need one for notes and one for homework.
Is this the same but shape?
Yeah, it's the same thing. So, and real fast, when you're graphing lines here that are inequalities, this should not take us more than 10, 15 minutes to get through, and I will allow you guys time to finish your homework before you get out of here today. So, a couple things to remember when you're talking about graphing of lines that are inequalities is whether or not you have solid or dotted lines. Your solid or dotted lines occur if you are less than or equal to or greater than or equal to, your line is solid. If it's just a less than or if it's just a greater than, it's dotted. Other than that, you graph things exactly the same as you would before. And there is one trick to remember when you're dealing with inequalities.
Which usually allow.
Not we.
Very nice.
Let me see it at least.
So, when you have the equation or the inequality 4x minus 2y less than or equal to 8, two ways I can go about graphing this. Solve for y. I get negative 2y is less than or equal to negative 4x plus 8. Divide by the negative 2. What happens when you divide by negatives? Yeah. Whenever you divide by a negative or multiply by a negative, you have to switch the sign. And then you're left with y greater than or equal to x minus 4. Yes, sir?
Can we just switch the y, the 2y to the other side and then switch x?
You can do that as well. The only thing that I do it that way is that it's, then you'd want to read it backwards. And I'll explain that in a little while. Yes, sir?
Oh, why does it flip?
It flips because when you're dividing by negatives, you're looking for a new truth. It's kind of weird how you want to explain it. If you put in here,
Oh, if the x or if the 2 or y was on the other side, Alex, and then the 8 was over here, you'd still end up with the same thing. Like, it's just like flipping it so that it's like reading it back. Like,
right. It's kind of along the lines of 2 is less than 5, but 5 is greater than 2. You read it backwards. It's kind of where Leaf was going. If I read it, bring this over this way. If you go with, if you go 4x minus 8 is less than or equal to 2y, it doesn't change, does it?
It's just flip.
It's just flipped. Okay.
Because you're switching the negatives, it makes that less. You're just switching the sign also.
Correct. What do you got?
Oh, they don't have enough graph paper right now.
Oh, you're not a graph paper? Went through that much graph paper already?
Agreed.
I know I do.
He said we needed 2 pages, so we're going to make sure we get those 2 pages.
Oh, I have some more. I know it's up there. I'll get some. Don't worry. No worries. Anyway, when you go to graph this then, when we go to graph this, we start at our y-intercept and then walk our slope. What's your y-intercept? Negative 4. Your slope is? Is this going to be a solid or a dotted line? It's going to be solid because it's a less than or equal to, or it's a greater than or equal to.
Oh, because it's.
And the reason why we say solid versus dotted, remember what we did yesterday with those piecewise functions. If it was less than or equal to -2, it was a solid dot on the point, on the coordinate. If it was less than, it was just an open dot. Same idea. This is a solid line when it's less than or equal to, or greater than or equal to, and then it's just a dotted line if the other one is true. Okay? Now the fun part, the shading. If you remember when you had inequalities in the past, when you had just regular single variable inequalities, you'd graph them on a number line. You would graph towards the direction of true. We do the same idea here, but instead of just picking one number, we have to pick an ordered pair. Well, there happens to be an ordered pair somewhere around here that is the easiest ordered pair to substitute in for if and only if the line doesn't go through that ordered pair. What is it? 0, 0. So what we're using here is what we call a test point. We are testing the point at which 0, 0, since it does not lie on the graph.
It's gotta be this side. So,
Bless you.
I feel you.
And what this line has done, it has taken our plane, our xy coordinate plane, and cut it in half. There's two parts. One side's true, the other side is false. What we are trying to do here is we're trying to be conspiracists. We are trying to cover up the truth. We are plotting against people.
That's rude.
Get it?
Plotting. Yeah.
That's not my joke. That was a kid in third hour's joke. It was very good. What we're doing is we're trying to see if it is a true or false statement. So what we do is we take 0, 0 if it does not go through that, and we always test back in the original inequality. Is 4 times 0 minus 2 times 0 smaller than 8?
Yes.
Is 0 less than or equal to 8?
Yeah.
Yes. So we shade, and that's all you got to do.
So easy. Just those lines.
That's it. You don't have to sit there and fancy shade it. It doesn't matter. As long as there's a couple of lines on there, it looks just fine. Yes, sir.
Explain that last part, how you figure out
You agree that there's two sides here.
that. Yes.
What we're trying to do is that we're trying to figure out what side is true.
Yeah, but how do you do
You pick any point that is not on that line, and the easiest coordinate that isn't on that line is usually 0, 0. So you substitute back into the original equation, or inequality, excuse me. 4 times 0 minus 2 times 0 gives me 0. Is 0 smaller than 8?
it? Yeah.
So is that a true statement?
Oh, okay. So
That's all it is.
true.
Yep. If it was a false statement where it was, I'd shade on the other side.
What's his
Soraya.
name? Oh, her?
It was very funny. That was very well played. Nope, that's going to come up weird. That didn't take a nice picture at all. All right, let's take a minute and try these two. Oops. It's like a samba line.
I hope you recorded. Yes, I really hope that was the recording.
If you want to see something funny, watch Third Hour. I slam dunked in Third Hour. It was pretty
Do it
awesome.
again.
No, it's a one-time deal.
Wait, you slammed on.
So take a second with your graphs, plot them, shade them, and we'll check them in a minute. Watch. All right, so that was fun. Let's check and see how we did. Like I said,
They look almost exactly the same.
this should not have been.
They're like exactly the same equation other than one number.
Yeah, they're pretty close.
Minus 2.
I'm going to show you a shortcut on number 11. See if you remembered it. -1, walk your slope. Oops, up 2 right. Is that a solid or a dotted line? That one should be up.
No, 0. 1 on 6 should be up 1. 1 on 6 should be up 0 and 9. 0 is less than 6.
Yeah, then it's better. Does it go through the origin?
No.
No. So we tested. Is 0 greater than -1.
Yes. I like the shape.
All right?
You always
Your shades.
On the next one, I'm going to show you the real easy way to graph this.
Hold on.
This is pretty easy.
Graph it by intercepts. Remember that?
Yeah. Oh, man.
Cover it. What's your y-intercept?
-2. No.
Cover it. What's your x-intercept?
Let's get it 3.
Oh, man.
Will it be a solid or a dotted line?
Say
Does it go through the origin?
No.
Is 0 minus 0 smaller than 6?
Yes. True.
Oh, that's true. That's
Once again, you can shade by intercepts. Yes, sir.
Will it always be the bigger part of our graph that is true?
No.
That's how it's happening.
It just happens to be dumb luck.
That's my choice.
Third
Okay.
time is the charm. So.
No, it's just dumb luck. Yes, ma'am.
I understand like which side to show.
Okay. What we're doing here, you're okay on the graph, right? The graph part's okay? So what you're, well, if you graph from the right spot, then even better. But what we're doing here is you pick any point that you want that is not on the line. And it just so happens that the point that's very, very easy to work with is 0, 0. So if 0, 0 isn't on the line, I substitute in for x and y. What's 2 times 0? What's 3 times 0? What's 0 minus 0? Is 0 smaller than 6? So is that true or false?
So why do you like
The dots on that side of the line.
that's not six, it's that whole side.
Okay, so
That's-
like
If the
If
line
the
happened
line
to,
started at +1, you would
yeah, if it was up here and this was false, by chance, I would still shade away. I would
but
shade.
if that was true.
If this was true,
then you would
then
go
I would shade on.
Down, down.
Then I would shade that way.
So depends on like what side of the line is on the
Mhm. Yep, that's all it is. That's all it is. All right, that's all it is. No, I understood what you were going at. 2 more. There's a trick. You will see this over and over again. Gentlemen, I've had it. I should not have to ask you this all the time. All right? It's your last chance. I'm going to split the trio apart. Okay? That's enough. Okay. One of the things you have to remember when you're working with these things is sometimes you will have x equal number, y equal number, but obviously it's less than or greater than type of problem. So you still have to remember how you plot those types of graphs. Remember, if it's x equals a number, is it a horizontal or a vertical line? It's vertical. What number does that go through? Okay. So when you plot something like that, it's x is greater than 5. Is that a solid or a dotted line through 5? Close.
so that's just what it.
That's it. But now you still have to shade. Correct. What side are numbers larger than 5?
Right.
On the right. It's fancy.
So isn't it like these type of problems? Is just one giant like block line?
Yeah.
Yeah.
What do you got? Since there's just one number, where are numbers bigger than 5 on a number line? To the right of it or to the left of it? That's all it is. Whenever you have just y equals a number or x equal numbers, fall back onto when you did stuff on a number line. It would be going that way. It just so happens that our number line right now is built into a grid where it's all, watch this, it's all going that way. Okay? That's all it means. So we always pay attention to this,
Whoa.
That's totally cool.
Whoa, that's cool.
and you double check this.
I think you're just showing off.
Oh, is that how you slam dunk?
Me? I never show up. All right. Some homework problems. You want me to do that other problem?
Oh, can you go back?
Yeah.
We're good.
Oh, I get it.
Can you go back so I can see
Yeah,
the
can we
problems
just
that
get
you're
on?
writing
Should
down?
we just do our homework? 'Cause we're done with it.
Oh, you want to do that one still? Let's do that one. Might as well do that one.
Uh,
Well, it's not going to kill us. All right. So y-intercept is positive 7. Slope is
Negative
-1.
one.
These are like easier than
Are they a solid or a dotted line?
solid.
Test point is 0 bigger than 7.
No.
No. So it's, oh no, where'd it go? So in this case, it was false there. So I have to shade above. Okay? That's a good example of when it happens to be false at 0, 0. All right? Not so scary?
Yeah.
Let me give you guys 9 of these to do.
Oh, so it's less than 11.
Told you, less than or equal to.
We can make a graph for our homework. That'd be a cool test.
Graph the homework.
Graph the number.
What's the probability or what's the chance?
No. It'd be like this is less than 9. Well, then it'd be like negative 5.
And then negative problems means I'm doing your homework. That's not happening.
That's okay.
Negative problems.
Oops.
Negative, like, up on the board, it's like negative, about negative 36.
Do those 9. It is on page 112, section 2.6, 36 through 44. Shade them and graph them.
What's the probability of us finishing in the next 17 minutes?
80%.
Is that our homework?
Right,
Yes, sir.